Hello, welcome back to Learn Physics. In today's topic, we are going to discuss about this waves. Okay, this is for class 11 students. Here in this chapter, we are studying first about the mechanical waves. There are mainly two types of mechanical waves. They are longitudinal waves and transverse wave. Longitudinal wave and transverse wave. Transverse wave. So what are these longitudinal waves? See here, first I am taking a cylinder which is having a movable piston. So I am giving the piston, I am compressing it, or I am relaxing it, I am taking it out, pulling it out. What will happen to the gas inside the cylinder? It will be getting compressed or it is getting relaxed. So the movement of the particles inside the cylinder will be in the direction of movement of the piston. The waves which are forming inside the cylinder also will be in the same direction of the movement of the particles. So the movement of the particles, and waves, propagation of wave is parallel to each other, then we can say it is longitudinal wave. Okay, so in a fluid, see, while we are giving a force in this direction, waves also forming in that direction only, isn't it? So compressions and rarefactions are happening in the same it's parallel to each other, so we can say it is longitudinal wave. So longitudinal wave means movement of the particles and the propagation of wave are parallel to each other, then we can say it is longitudinal wave. Next is transverse wave. What is meant by a transverse wave? See, movement of particle and the wave propagation are perpendicular to each other. How we can explain that one? See, in the case of guitar, what we are doing? We are giving a movement like this, but a waveform is forming in that direction, isn't it? And if suppose I am giving a string is fixed at one end and the other end I am keeping it in my hand, I'm giving a jerk like this, what will happen? Particles will be moving in this direction, isn't it? But the waveform which is forming will be moving in that direction. So jerk is happening in this direction, particles are moving in that direction. That is, it is perpendicular to each other. That is called a transverse wave. Okay, clear? So these are the two types of mechanical wave, that is longitudinal wave and the transverse wave. Okay, clear? So now how we can represent these are the waves are moving from one point to another, isn't it? So we can call it as progressive wave. It is moving from one point to another point. It's a progressive wave. How we can represent a progressive wave? So in the last chapter we learned about the oscillation. Oscillatory waves, how we can represent the oscillatory wave? Oscillatory wave is A sine A cos omega t plus phi or sin omega t plus phi. Like that we represent it. But here in the case of our waves or progressive wave, displacement of a progressive wave can be represented as y of xt equals A sin kx minus omega t plus phi. This is for positive x direction. Okay, if the wave was moving in the negative x direction or negative direction, how we can represent the wave? Y of xt equals A sin kx plus omega t plus phi. This is the representation for negative direction. Here in this A, omega and phi, these are familiar for you since we learned it in the oscillation chapter, right? A is the amplitude of the wave, omega is the angular frequency, phi is the phase change, okay, phase constant. So kx minus omega t plus phi is called a phase term. What is k here? K is called as wave number or angular wave number. Okay, here in the case of the previous waves, the same way we can represent amplitude A. How we can define amplitude A? It is the maximum displacement of the wave from the equilibrium position. Okay, so if we are considering a wave in this manner, okay, this is the equilibrium position, right? So if this is the equilibrium position, which is the maximum displacement, this much. So this is called the amplitude A. Okay, omega is the angular frequency. Angular frequency, how we can represent? Frequency means it is the number of waves passing in 1 second. That is called a frequency, isn't it? Frequency equals number of waves passing through a particular point in 1 second is called a frequency of a wave. Okay, now, oscillation means we told number of oscillations in 1 second, isn't it? Here in the case of wave, we will say number of waves passing through a particular point in 1 second. That is called a frequency. So if it is angular frequency means we will convert it into angle, that is 2 pi into frequency, that is angular frequency. So we are going to represent all those things. Okay, so k is the wave number. Okay, so next is what is a wavelength? Wavelength, how we can represent, how we can define wavelength? Wavelength is the, see, the distance between two consecutive crust or trough, like that and all you can define. This is called a trough. This is called a crust. Okay, so this will, otherwise we can say this will be the regions of compressions and this will be the regions of rarefaction. The distance between two consecutive compressions or rarefactions are called as the wavelength, or we can say the minimum distance between the 2 points having same phase. Two consecutive points which is having same phase. Phase means same phase angle. See here, if I am considering 0, see in 0, then pi by 2, 2 pi. Okay, so this is pi, 2 pi. Okay, so again I am considering, this is one wave. In that, if I am considering pi, so for the next wave I should consider pi. Next wave, see next position, it is the, this is the next wave, second wave, isn't it? This is the first wave. Okay, for the second wave this is 0, this is pi by 2, this is pi. So while we are considering the waves, the two consecutive waves I am considering and the minimum distance between the two consecutive waves which are having same phase, that is called a wavelength. That is pi, or in between points also we can consider. So which are the two consecutive points which are having same phase, the distance between the 2 points which are having same phase, that is called a wavelength, or we can simply say it is the distance between the two crust or two trough, that also we can say. Okay, distance between two consecutive crust or trough, that is called a wavelength, or the minimum distance between the two consecutive waves which are having same phase are called as wavelength. It is represented as lambda, unit is meter. There is a relation connecting k and lambda. K equals 2 pi by lambda. Okay, this is the relation connecting k and lambda. Next is angular frequency omega. Omega equals 2 pi into nu. Nu is the frequency. Okay, so this is angular frequency omega. Okay, omega is the angular frequency. Unit is radians per second. Unit is radians per second. Okay, and frequency and time period. Nu equals 1 by t. As we told in the previous oscillation chapter, same way period is the time required for the movement of one wave. Okay, what is the time required for the movement of one wave? That is called a period of the wave. Period means time required for a movement of one wave is called a period. Nu equals 1 by t. Okay, so these are the formulas which you should remember. Okay, so now we will do one solved example question in the textbook. Okay, so this is from page number 368, that is second question. Okay, 368, second question. A wave traveling along a string is described by y of xt equals 0.005 sine 80 x minus 3t, in which the numerical constants are in SI unit. Okay, calculate amplitude of the wave. What is the amplitude? See, first you can write down the general expression A sine kx minus omega t. Phase constant is 0 here. So A equals 0.005 meter, because in SI units it's given, right? So it's meter. Then next is wavelength. Wavelength, how we can write down? See, k equals 80. So k equals 2 pi by lambda we learned. So lambda equals 2 pi divided by 80 meters. Okay, so here next is what is that? Period and frequency. Period and frequency, how we can find out? Omega equals 2 pi into nu equals 3. Nu equals 3 by 2 pi and t equals 2 pi by 3. Second, this is second to the power minus 1. Okay, just compare. You should know the general formula. If it is a progressive wave, you should write down in this manner. Okay, then next is also calculate the displacement of a wave at a distance x is equal to 30 centimeter and t equals 20 seconds. So here x you can substitute as 30 and t you can substitute it as 20 seconds and can find out the rest of this value of y. Okay, here just substitute and find out the answer. Okay, while you are calculating here, since this is angle, you should use pi and all, pi only. Okay, but here and all you can use the value of 3.1 for that, since it is not in radians. Okay, so next we are going to find out what is a speed of a traveling wave. Okay, speed of a traveling wave. Okay, so progressive wave we are considering, what is the speed? Okay, one wave, if I am considering one wave, it is moving in this direction. Okay, this is the movement of a wave. Okay, after some time, if I am checking where is the position of that wave, maybe that wave will be moving in this manner. That is, after delta t time interval, it is moving a distance of delta x. Okay, but the same wave. So phase will remain constant. Okay, we know that y of xt equals a sine kx minus omega t is, this is the wave. Okay, no phase difference and all, phase constant is not there. So ka sine kx minus omega t. But here the same wave after delta x time, if I am considering, whether any change in phase? No change in phase. That is kx minus omega t remains constant. Okay, so I can write it as kx minus omega t will be equal to, if it is traveling a distance of delta x in an interval of time delta t, kx minus omega t will remain same. Right? So we can write it as kx minus omega t equals kx plus k delta x minus omega t plus omega delta t. So kx will cancel, minus omega t will get cancelled. You will get it as, here it is negative. K delta x equals omega delta t. So what is delta x by delta t? It will be omega by k. What is delta x by delta t? Dx by dt is velocity or speed of a wave, omega by k. Now I am going to multiply 2 pi in the numerator as well as the denominator. Okay, what is this 2 pi by k? 2 pi by k is lambda. So instead of 2 pi by k, I can write it as lambda. We know that omega equals 2 pi into nu. Okay, what is omega by 2 pi then? It will be nu. So omega by 2 pi, I can write it as nu. So we are getting another formula, v equals nu lambda. This is the speed of a traveling wave. Okay, clear? Next we are going to do the speed of a transverse wave. Okay, transverse wave. Transverse means if it is moving through a string. Okay, so that is transverse wave. Okay, here we are adopting dimensional analysis. Speed of a transverse wave is directly proportional to the tension acting on the string, and it is directly proportional to the mass density. What is the mass density? Mass per unit length is called mass density. Okay, since it is depending on tension and mass density, we can write it as t to the power x and m to the power y. Okay, so here I will write it as V is tension. What is the dimensional for tension? Tension is force acting on it. So m l t to the power minus 2 to the power x. Dimension of m by l, that is m l to the power minus 1. Dimension of b, l t to the power minus 1. That is equal to, so substituting over here, L t to the power minus 1 is equal to a constant k into t to the power x. So m L t to the power minus 2 to the power x. Here m L to the power minus 1 to the power y. Okay, so while we are comparing mass, equating the powers of m, equating the powers of m means 0 equals x plus m to the power x, m to the power y, so x plus y. So L, equating the powers of L, so here 1 equals here L to the power x, L to the power minus y. Okay, then equating the powers of t, so here minus 1 equals here minus 2x. So what is x here? X equals 1 by 2. So what is y here? Y equals x minus 1, 1 by 2 minus 1. So we will get it as minus half. So substituting in this equation, we will get, substituting this 2 and 3 in equation 1. So substituting the values of x and y in equation 1, b is equal to or V is equal to K into T to the power, what is that? T to the power half. And mass density if I am writing it as rho L, that is to the power minus half. So that will be divided by half. So here we can write it as K into root of T by rho L or mu. Mu is the term which is used in your textbook. So I am also giving the value mu. So m by L is given as mu to the power root V equals K into root of T by mu. This is the speed of a transverse wave. Okay, so clear? So these are the some of the introductory portions in the chapter waves. Okay, so I hope it is clear for you, and if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.